Avogadro's law. When we hear the word Avogadro, we associate this with Avogadro's number, which is 6.02 times 10 to the power of 23. In Avogadro's law, for gases, it investigates the relationship between two variables of volume and amount of gas expressed in moles, so somewhat related to Avogadro's number. So in this diagram, it tells us that if you are pumping molecules to a certain container, when you increase the number of particles in a container, in an expandable container, you would expect that at constant temperature and pressure, the more molecules there are, that means the more space they're going to occupy. So you would increase the volume of the container. On the other hand, if there are few particles present in a container at the same temperature and pressure, you'd expect that they take up a lower amount of space for that number of particles. So you would expect that in Avogadro's law, it's the relationship of volume and amount of gas in moles is just directly related. What are the different applications of Avogadro's law? The first common application is breathing. When we inhale, we take in a lot of oxygen molecules and therefore our lungs expand. When we exhale, we decrease the amount of gas inside our lungs, and so therefore the volume of the lungs decreases. Application 2, if you have two identical balloons and one balloon is filled with helium but the other balloon contains air. So when we say air, that's a combination of the different gas molecules, oxygen, nitrogen, carbon dioxide, and so many more. And helium is the second lightest gas. So that means between the two balloons that are identical in volume, since helium weighs less, so that means our helium balloon is lighter compared to the one filled with air. On the other hand, by simply blowing a balloon, you are already representing the Avogadro's law principle, because it says that the more you blow more molecules of air into the balloon, of course it's going to expand. So it gives you the direct relationship of volume and N. So Avogadro's law will become V is equal to constant times N. So volume is proportional to the number of moles of a gas. In terms of an equation form, and because they're directly related, the equation will now become V1 over N1 is equal to V2 over N2, in which if you multiply this, you're going to have, let me write that, you're going to have V1 N2 is equal to V2 N1. And so that's going to be the final horizontal format of Avogadro's law for this particular concept. So that is for Avogadro's law. Let's try to proceed to the problem solving of that. Let's try to proceed to a problem solving on Avogadro's law. If 5.50 moles of carbon monoxide occupy 20.6 liters, how many liters will 16.5 moles of carbon monoxide occupy at the same pressure and temperature? So we all know that we are given N1, which is 5.50 moles, and then we're given, of course, the volume of that N1, which is 20.6 liters. And then you're asked how much will be the liters, how many liters will 16.5 moles. So that's going to be your N2, 16.5 moles of your CO. So it's obvious that you're going to be asked to solve for V2. So from our formula, V1N2 is equal to V2N1. So to get V2, we divide both sides by N1. So that's going to be our final equation. Now we're ready to substitute. Let me just reverse the side. So V2 is equal to 20.6 liters times 16.5 moles over 5.50 moles. So cancel out the mole, we're going to get the liter unit, and the final answer is 61.80 liters of carbon monoxide gas. So that's simple. It's going to be just like that. So take note that it's just that you need to identify the right values so that you'll be able to know what to substitute so that you can get the accurate answer in the last part. And so for checking, take note, it's 61.80. And since it's a direct relationship, and we know that from N1 it's 5.50, it increases to 16.5. So we would expect also that your from 20.6 liters of V1, it should increase to a certain value higher than 20.6, which is clearly represented by our answer, which is 61.80 liters, which is really greater than your V1. So it represents the direct relationship of your volume and amount at constant temperature and pressure. So that's it for now. Please solve more problems and don't give up. And this is Madam Narca saying, don't stop learning, unlearning, and relearning. Please do like, share, and subscribe to my YouTube channel. Thank you so much. God bless you.